what we're going to be doing today in this lesson is defining, identifying, determining reference angles and arcs for any given angle or arc. So you're going to have some new vocab and some new notations in this that we do want to focus on. So we're building some of those skills throughout this lesson. So if I gave you these two scenarios and I asked you to sketch them, think about what they would look like. So as you ride a Ferris wheel, your distance from the ground depends on how long you've been riding, right? So maybe you start and you're this far above the ground and then it's going up. And then you get to the top and oh, you're gonna come back down. And then it gets back down to that lowest point, it goes back up and down and up and down, right? And that just keeps repeating. That's not very nice, but it keeps repeating because it's your distance from the ground. So think about when you're graphing it, this is maybe your x-axis is maybe time, and this is maybe distance from the ground. So it's not how far you've traveled, like the length unraveled, but it's your distance from the actual ground at each point or each time interval. What about this? The depth of the water at the shore depends on the time of day, right? So like this is like tides is what this is looking at. Right, like high tide and low tide. So the depth of the water at the shore. So maybe at high tide, it's up here. And then it gets to low tide at some point. And then, oh, it's going to go back to high tide and back to low tide. And it has this repeated cycle that it always follows, right? Like you know that. So this is the depth of the water versus time. So what these scenarios are called are periodic functions. They're periodic, meaning like they repeat and they have cycles that continue. So the dependent variable y takes on the same set of values over and over. What does this mean for the domain and range? Well, the domain is going to be infinite, but the range is going to be between two set values. Maybe like if we were talking about that Ferris wheel, the lowest point to the highest point, and then it just keeps repeating and it bounces back, right? Like it's between those two values the entire time. So given a circle, how far can a point travel around or rotate before it begins the same path, right? Like it has a circular path. So, well, if it goes around in that circle, that's what we know as 360 degrees. Positive travel around a circle is counterclockwise, and I think this is very important for us to know. If you make the connection even with the quadrants, right? You start in the positive, and you go counterclockwise. It's 1, 2, 3, 4. So make that connection there. Positive travel is counterclockwise. Negative travel is clockwise. So does the size of the circle change your answer for any of this? No matter what, you're going around 360 degrees. Any circle, it doesn't matter what the radius of that circle is. So some vocab and notation. This is what we call the initial sign. We've got an angle, remember it's going counterclockwise if it's positive. There's our angle. That's what we call that terminal side. That's like the terminal ray. So you have an initial and a terminal. Where do you start? Where do you end? You're always starting on the positive x-axis. That is always your initial side. This is the positive x-axis. So if we said, we'll call this theta, right? If theta is 45 degrees, if you rotate counterclockwise in the positive direction, this is a 45-degree angle. If we went clockwise instead, that same amount, that is what we call negative 45. So the angles are in what we call in standard position. Popular letters for these angles are Greek letters, right? So like I have theta here and beta, but sometimes you'll see alpha. Sometimes you'll see gamma, not too much in this class. Sometimes you'll see omega. So the Greek letters are what are going to indicate the angles. They're like variables. So the initial side, terminal side. That's quadrant 1, quadrant 2, quadrant 3, quadrant 4. So notice that quadrant 1 is between 0 and 90. Quadrant 2 is between 90 and 180. Quadrant 3 is between 180 and 270. And quadrant 4 is between 270 and 360. So which quadrant do these angles terminate in? Which angles do they lie in or end in? So right here, 100 degrees, well, where does that fall? That's going to fall between 90 and 180, so this would be in quadrant 2. What about 47 degrees? Well, that's between 0 and 90, so that's going to be in quadrant 1. 183, so that's going to be, oh, that's more than 180, so that's going to end up in quadrant 3. 295, that's going to end up in what? Quadrant 4. Negative 100. Oh, that means I'm going to start here on my initial side, and I'm going to be going clockwise. Right? Oh, this is going to be negative 90. I'm going to go 10 more degrees on that. Oh, I'm actually going to end up in quadrant 3. What about negative 270? I'm going to start here on my initial side, and I'm going to go clockwise, 90, 180, 270. So negative 270, I'm going to end up, it's not really in a quadrant. This is called a boundary angle. Right? And so I'm going to say it's in the positive, on the positive y-axis. It's not really in a quadrant. 0 and 360 degrees are called coterminal angles, right? They terminate in the same place. They end in the same place. Coterminal angles are two angles in standard position that terminate in the same place. So a way that you can find it, sorry, this got a little bit messy, is you can think, well, I have to figure out a coterminal angle, I can take the angle I'm given and I can add or subtract 360 times n, where n is any integer, right? Like if I just add 360, it means I'm going around one time counterclockwise. If I add 360 times 2, which is 720, I'm going around twice. So there's an infinite number of coterminal angles, and I can also subtract it. So, reference angles. We talked about coterminal reference angles. So here, theta is a reference angle. It's 45 degrees. So things that we should know about a reference angle is that they're always positive, they're always acute, and they're always closest to the horizontal axis of where the terminal side is. So if you're in quadrant 2 or 3, your horizontal axis is going to be the negative x-axis. If you're in quadrant 1 or 4, your horizontal axis is going to be your positive x-axis. So 45 degrees is actually the reference angle. You want to think about if you were to draw a triangle or drop a perpendicular to the horizontal axis. So right here, this is 135 degrees, right? Like this angle or this arc is 135 degrees. The reference angle, I would want to go to where this terminates and drop a perpendicular. So this right here is my reference angle. Well, what is the measure of that reference angle? 45 degrees. All right, so even though theta is different, the reference angle is the same. If I go down here to 225 degrees, I would again want to drop a perpendicular to the closest horizontal, not the vertical, the closest horizontal, and then think about, well, what is this angle? Because that's my reference angle, right? And again, I'll check that out. It's 45 degrees. I can do one more. This is 315, right? You start here and you go all the way around to 315. But when you're talking about a reference angle, I'm going to drop that perpendicular to my closest horizontal right there. What is this angle? Oh, it's 45 degrees again, right? So I'm saying how many degrees does it take to get there? How many degrees does it take to get to 360 is almost what I'm looking at. So Determine the reference angle for each of these. So the first one that I have is 100 degrees. Oops. I'm gonna try to do this in a few different colors. So 100 degrees. It starts here. 100 degrees is gonna be a little bit more than 90. So like right here. So I'm gonna sketch that angle first. This, so that looks very nice, is 100 degrees. My closest, it's in quadrant 2, my closest is right here. So I want to think about, well, what is the measure of this angle right here? That's my reference angle, right? What is the measure of that? Oh, well, if this is 100, well, what is this part that's left over? Oh, that's 80 degrees. My reference angle then is 80 degrees. What if you had 47? Get a new color. 47, well, that's going to be in quadrant 1. Right, if I wanted to sketch it, that might be like about there. And from here to here, that's 47 degrees. Well, if I dropped a perpendicular, it's just the angle I'm given. It's just 47 degrees. What about if I wanted 443? I'm going to go around the circle. Well, that's 360, and I'm going to keep going, right? How much more than 360 is that? That's another 73 degrees. So I went around the circle, and then I went, so it's not quite 90, it's gonna be less than that. So it's like, it terminates like here. So I'm actually starting, let's say I was gonna sketch that. I'm gonna start here and I'm gonna go all the way around and then to here, right? With that leftover part, like this is 443, but I went 360 and then an additional, what was that, 73? So if I drop that perpendicular, what is my reference angle? It's just 73 degrees. All right, 73 and 443 are actually coterminal, aren't they? The way we worked that one out, because that terminated in quadrant 1. Let's see. So negative 287. So that's going to go the other way. So I'm going to start here. Again, I'm only starting on the positive x-axis. And I'm going to go negative 90, negative 180, negative 270, and a little bit more. Right? So I don't know how well I can do this. I'm like making some of, I'm not making them up. These are not my most beautiful. So I'm going like, woo. But I drop that perpendicular, and what is this angle here? Well, you almost want to think, how much more would I have had to go to get to 360? Well, you would have had to go 73 more. Whoa, it had, so I should have actually ended these two on the same place. These two actually have the exact same reference angle. These angles are actually coterminal. How cool is that? What about this next one? I'll do some blue. Negative 100. So negative 100, I'm starting here. This is 90. I'm going to go a little bit more. I'm going to go, woo, and that's negative 100 degrees. Right? So if I go to the closest horizontal, if that's negative 100, how much is that reference angle? How much is this right here? It's got to be 80, right? This is 80 degrees. And that final one, that 270, so you're going to be going 1, 2, 3, right? Oh, this is 270. That reference angle, oof. It's like not really there, right? So this one, there's not really a reference angle. We're going to treat this different because this is what we refer to as a boundary angle. So just know these ones that end up on the axes are even more special. They're called boundary angles, and we are going to deal with them separately from the idea of reference angles. So if you want a rule for how to come up with these reference angles, if you're not feeling confident with like visualizing it, we want to get you there, but think about it like this. If you're in if your reference angle, if the angle you're given ends in quadrant 1, if your theta is in quadrant 1, that is your reference angle. So here, theta is the angle you're given. In this quadrant, it's just theta. In this quadrant, you can do 180 minus theta because you're trying to find its supplement. Remember that from geometry? In this one, you're going to do theta, the angle you're given, minus 180 to see, well, how much over 180 did we go? And in this one, you want to see, well, how far is it from being a full circle? How far is it from getting to that axis? So this is like, how far is it from getting to the x-axis? How far is it over the x-axis? How far is it from getting to the x-axis? So if you want more of a formula idea, feel free to use this. But also keep in mind, these are not things you want to take forever to work through. So try to build your ability and capacity of this and your speed. Let's do some examples. Sketch the angle and determine the reference angle. So 30 degrees. Here's the 30 degrees. Right? The reference angle is just going to be 30 degrees. What about negative 50? This is just going to be 30 degrees. Negative 50. Did I have that one on there? No. Negative 50 is going to be like down here. Let's sketch it. That reference angle, well, it's always positive. It's actually just going to be 50 degrees. Think of it like absolute value. What about positive 175? Well, that's more than that's less than 180, so it's going to be a little bit above here. So I'm going to go, woo, 175. So your reference angle, well, what is this right here? What's this little angle? We're going to do 180 minus that 175. How much do you have left over? Oh, your reference angle is 5 degrees. So you can think about this as like an exit check or just some more practice with it, but let's do a few more. So we want to sketch the angle or the arc, write down the reference angle, and identify a positive and a negative coterminal angle. So I'm going to sketch this. Let's see. So I'm going to start right here. And I'm going to go 372 degrees. So I'm going to be going around the circle and then a little bit more, right? So that was pretty good. This is 372 degrees, that whole way around. That's how I'm going to sketch it. Okay? My reference angle, well, I want to think, how close is this to the perpendicular? What is this little distance? Well, think about how much more did you go than a full circle? Right? If you want to think about, well, how much beyond 360 was this? I think that's 22 degrees. My reference angle is 22 degrees. To figure out a coterminal angle, well, I can do 372. What if I subtract 360? Oh, isn't that 22? So there's a positive coterminal angle. I could have added 360 and that would have worked, right? Answers can vary here. And then to figure out a negative one, well, why don't I subtract 360? And figure out if you took away 360 from that, where are you going to end up? Oh, negative 338. And again, there's more than one answer. I'm just doing the two that I come up with. Here we're given it in radians. So we still want to think about the arc here. So I'm still going to start here. Well, 13 pi over 6, that's actually more than a full circle, right? That's more than 2 pi. So I'm going to be going, woo, and a little bit more, right? And that's going to be 13 pi over 6. Well, how much beyond a full circle did I go? How much beyond 2 pi did I go? Pi over 6. Right? You think about how much past 2 pi. Well, 12 pi over 6 is 2 pi, so I'm going just pi over 6 more. For this one, I'm not going to add and subtract 360. What am I going to do? I'm going to add and subtract 2 pi. So, well, if I do 13 pi over 6 minus 2 pi, so I'll say 12 pi over 6, I get pi over 6 is a coterminal angle. If I do pi over 6 minus 12 pi over 6, right, subtracting 2 pi, which is the equivalent to 360, I get negative 11 pi over 6. keep going. Maybe this is the time if you haven't paused it and tried this on your own, you're trying it. Negative, that means I'm going clockwise, so I start here. It's not quite a full circle. It's going to be a little bit less, isn't it? So I'm going to go, woo. You have to make the noise when you do it. That's negative 7 pi over 4. Well, how much was I away, right? Like if you think about the reference angle, it's just this little part. How much away from 2 pi were you? Pi over 4, right? If I have one more pi over 4, it's going to give me a full circle. So the reference angle is going to be pi over 4, positive, right? So negative 7 pi over 4, let's add 2 pi to that and go around the circle and see what we get. So I'm going to add 8 pi over 4. I get pi over 4 as a reference angle. Let's say I'm not going to add again. I'm now going to subtract 8 pi over 4. If you add it again, you're not going to get a negative, and we wanted a positive and a negative. If I subtract 8 pi over 4, which is just 2 pi, I'm going to get negative 15 pi over 4. Last to 280, that's not quite a full circle, right? It's going to be more than here, because this is 270, a little more, like 10 more than that, right? So that's 280 degrees. What's your reference angle? How much was I away from a full circle, right? What is this right here? I think it's 80 degrees, right? If I add 80 more degrees, I'd be at 360. So my positive and my negative, let's see. If I take 280 and I add 360, what do I get? So if I'm at 280 and I add that, I have 640 degrees is a coterminal angle. If I subtract 360, I get that negative 80 is a coterminal angle. What about this last one? Sketch. So negative 350, oh, it's not quite a full circle, right? But I'm going to be starting here, and I'm going to go, I don't quite get there. I get pretty close. How close do I get? How much away am I? 10 degrees, right? So my reference angle is 10 degrees. If I do negative 350 and I add 360, I get 10 degrees as a coterminal angle. And I do negative 350 minus 360. Sorry, my pen's kind of getting wonky. I get, what is that? Negative 350 minus 360. I get negative 710 degrees. Right, so identifying those reference angles are important. Knowing how you can figure out a coterminal angle so that you can work with smaller numbers as we move forward is going to be important for us. And being able to do this quickly, like thinking through which quadrant is it in and what is it equivalent to, is going to help you a lot as you're moving forward, especially into even the next lesson this week and in general. So it was important that we go through some of this terminology and how you identify those pieces. So in this lesson, what we did was we defined, identified, and determined reference angles and arcs for any given angle and arc, as well as coterminal. I don't know why I left that out, my bad. If you have any questions, please let me know. Otherwise, please make sure that you complete the actual homework textbook assignment because it is going to be submitted this week. And if you have questions about that, please reach out and let me know. Thank you.